Welcome to the Deep Dive from Sand Science Experience, your source for the most current and impactful research and preprints in science. Please do hit that like button and subscribe right now. It really helps support the Sand Science Experience and lets us keep bringing you these deep dives. Okay, so today we're plunging into some, truly groundbreaking research, stuff that could really change how we understand aging and, the very end of life.
Indeed. We're looking at a fascinating new paper. It explores something scientists are calling the Smurf phenotype.
Smurf phenotype?
Yeah, it's a surprising physiological signature. It seems to predict impending death, not just in the usual suspects like fruit flies, but now, excitingly, they found it in mammals, too.
Wow. Okay, so our mission for you today, then, is to explore this idea of a Sutter-Smurf transition. What is it? How have scientists actually observed it in different animals? And crucially, what are the implications, for how we think about aging? Maybe even predicting when someone is nearing the end. Okay, let's unpack this. So, first off, the term Smurf. It definitely catches the ear. It's not about little blue cartoon characters, I assume. Where did that name come from in, serious research?
Right, definitely not the cartoons. It's actually quite interesting. The whole concept started in studies on Drosophila.
Fruit flies.
A common fruit fly, exactly. Researchers found that when they fed these flies a blue food dye, a non-toxic one, some flies would, suddenly turn blue.
They turn blue.
They literally turned blue. Oh. And it wasn't just some, quirky thing. It signaled a really critical change. Their intestinal permeability had increased. Meaning the guy was leaking from their gut right into their general circulation. And here's the kicker. These blue flies, the Smurfs, they were consistently very close to death.
Regardless of their actual age.
Regardless of their chronological age. That was the really surprising part.
Wow. So it's not this slow, gradual decline we often picture. It's like an abrupt switch.
Precisely. It's an abrupt shift. And this observation led them to propose what's called the two-phase aging model.
Okay, 2 phases.
Yeah. Phase 1 is basically a healthy period. Your risk of mortality is low, but your risk of tipping over into phase 2, that increases as you get older.
And phase 2 is the Smurf phase.
Phase 2 is the Smurf phase. It's marked by that sudden onset of these physiological issues like the leaky gut and a very high, very immediate risk of death. It's a distinct state.
And you mentioned this isn't just a fly thing.
No, not at all. And that's what makes it so potentially significant. Researchers started looking and found this Smurf phenotype, or something very like it, seems to be evolutionarily conserved.
Meaning it pops up in other species?
Right. They've seen similar things in nematodes, tiny worms, and even in zebrafish. So the big question for this new study was, does this hold true for mammals? They used musculus, the standard lab mouse.
Okay, so they tried to find Smurf mice. What exactly did they do?
Well, they ran a pretty extensive longitudinal study. Hundreds of mice. They tracked them from adulthood all the way through to natural death.
Measuring what?
Lots of things. Numerous physiological parameters, metabolic markers, even molecular changes. And guess what they found?
The Smurf transition.
Pretty much, yeah. Just like in flies, these mice showed a really distinct increase in intestinal permeability, that leaky gut marker, in their final weeks of life.
How final? Like days, weeks?
Typically around 10 to 31 days before death. It varied a bit depending on the specific mouse strain and the sex of the mouse.
Okay, so measurable sign appears weeks before the end. What else changed? Was it just the gut permeability?
No, that was just one part of a whole package, really.
Okay.
They saw this abrupt, kind of synchronized deterioration across several areas.
Like what?
Things like a sharp drop in blood glucose. They lost body weight and fat mass quite suddenly. Their food intake decreased. They had trouble regulating their body temperature.
Wow.
And even signs of chronic, sort of low-grade inflammation starting up.
Yeah.
It all happened together.
Which raises the big question, right? If these changes are so consistent, can you actually use them to predict death, separate from just knowing how old the mouse is?
And the answer seems to be yes. The study clearly showed they could distinguish the Smurf mice from the non-Smurf mice just using a combination of these biomarkers.
Even if they were the same age?
Exactly. Even if they were the same chronological age. The Smurf mice consistently had a much shorter remaining lifespan. They even built a predictive model.
Based on what?
Just tracking 4 things. Body temperature, fat mass, blood sugar levels, glycemia, and that intestinal permeability marker. Those 4 allowed them to predict impending death pretty well.
Can you give an example?
Yeah, they highlighted 2 mice in the paper. Mouse 1 had this deteriorating profile, fitting the Smurf criteria. Mouse 14 looked healthy based on those markers. Both were the same age, but mouse 1 died much, much sooner.
Okay, this is huge. So what does this all mean, stepping back? This two-phase marl, now seen in mammals, it really seems to challenge that old idea of aging as just one long, slow, continuous slide downhill.
It absolutely does. It suggests there might be this sort of common public path to death.
Mm-hmm.
One characterized by this fairly abrupt transition, this Smurf phase.
And the implication there is?
Well, it could allow us to measure someone's physiological age, how aged their body systems actually are, rather than just counting birthdays, their chronological age.
That could be incredibly useful.
Right. And it also helps untangle which age-related changes are just due to time passing versus those specifically linked to this final terminal decline. They show that quite neatly with gut microbes, actually.
How so?
They look at the gut microbiota. They saw some changes just associated with getting older, sure. But then during the Smurf phase, they saw these distinct, abrupt shifts in the microbial community that only happened then.
Suggesting those specific gut changes are part of the end-of-life process itself, not just general aging.
Exactly. It helps separate the signal from the noise, so to speak.
Okay, so the unavoidable question for everyone listening. Could this apply to humans? Is there a Smurf transition in us?
Well, that's the million-dollar question, isn't it? We know that increased intestinal permeability, leaky gut, is already observed in humans, particularly in critically ill patients, like those with sepsis.
So there's a potential link there.
There's a link. Now, you can't just take the mouse model and apply it directly to people, of course. It's more complex. But these findings absolutely provide strong support for exploring this further in humans.
Are people looking into it?
They are. In fact, there's already a clinical trial underway. It's called Blu-ray. They're specifically looking to see if this kind of model, monitoring these biomarkers, can help predict outcomes for patients in intensive care units.
Wow. So it's already moving towards clinical investigation.
It is. It's early stages, obviously, but the potential's definitely there.
So wrapping this up, instead of thinking about aging as just one long, slow fade, this deep dive suggests there might be this, maybe even universal, two-phase process, a healthy period, and then for some reason an abrupt Smurf transition kicks in, signaling that final critical stage of life. It really makes you wonder.
It really does.
Yeah.
I mean, imagine if we could reliably identify when someone is entering this Smurf transition in humans. What could that mean?
Yeah, the implications are huge. Proactive healthcare.
Maybe. Managing end-of-life care differently, perhaps more compassionately or effectively, even potentially redefining what we mean by old age, shifting focus from years lived to physiological state.
Yeah.
It certainly gives us a lot to think about.
A truly thought-provoking deep dive. Thank you for walking us through that. We hope this exploration has given you some really insightful nuggets to consider from the SANS Science experience. And hey, don't forget to like this video and subscribe for more deep dives into the latest, most exciting scientific research. Thanks for joining us.